Good morning, everybody. Good afternoon. My name is Paul. I'm working for a company called Micrographics, and we're doing a webinar today on Autodesk Revit and generative design. It's meant to be just an intro, so we won't be spending too much in the details of it, and it's essentially meant for those that would like to automate and optimize solutions within Revit. So I will be flipping between the internet and the PowerPoint presentation today. The reason is because most of the information will be contained on the internet in any case. And if I had to reproduce everything on slides, it won't work very well. So on the agenda today, we're going to look at Autodesk Generative Design, which is working together with Autodesk Dynamo, and the optimization engine behind that is Autodesk Refinery. Having a look at what is generative design, in essence, a collaborative design process between humans and computers. During this process, the designer defines the design parameters, and the computer produces design studies, alternatives, evaluates them against quantifiable goals set by the designer, and improves the studies by using results from previous ones and feedback from the designer, and ranks the result based on how well they achieved the designer's original goals. In essence, this is what is known as machine learning. It's a brute force exposition of different solutions and then evaluating which solution is the best based on criteria. So if you had to look on the screen there by that little polygon, there is a design envelope. So you would have 1, 2, 3, 4, 5, 6 evaluation criteria. And this specific solution that you see on the screen would fall within the cyan element that you see on the envelope. So it's falling within that part of the design envelope. So generative design is a specific application of computational design approach with the following distinctions. The designer defines goals to achieve a design rather than the exact steps. So it's an idea. Computer helps the designer to explore the design space and generate multiple design options. And when they say not just one, it might be millions. In a time that wouldn't be possible for a human being. The computer enables the designer to find a set of optimal solutions that satisfy competing goals. And then the designer compares multiple design scenarios to find a set of design options that fits the design goals. To delve into how all of this fits together, we have to consider Autodesk Dynamo. You might have come across the name before. And within Autodesk Dynamo, we automate using Revit nodes. These are already designed by Autodesk. Then when we are not able to do what we need to do with the Revit nodes, we typically look for packages that are already defined nodes written by others. And then we can also automate using Python and the Revit API. So I'd like to illustrate that for you on the screen. I've opened Revit in the background over here. And this is an example, for instance, of what a typical, or rather large, but a typical Dynamo graph might look like on a production line. So I'm just going to scroll through there and show you how these are nodes that are logically connected to each other. This illustrates the flow of the idea. So it's very much like a computer program, which then feeds further and further into logic. And along the path of the logic. So we set up, in essence, a computer program that achieves some or other goal ultimately. Now, in this case, this program that I'm showing you, or this graph, as they are called, this graph is quite heavy on resources. So specifically, when you run Dynamo graphs like this against large models, you want a lot of RAM. 32 gig RAM on this package on a large model, or on this graph on a large model. 32 gig was occupied for about 10 to 15 minutes at 100%. So of course, if you have 64 gigs of RAM, then that would work out to a faster evaluation of this specific routine. You can see it can get quite large, relatively complex, but it doesn't have to be that complex. I'd like to show you what the Python node looks like. So we're just opening the Python node in the background. Right, so here is an example of where a short script was used through Python to read the enumeration of the part type of an HVAC component. And then the result of that was ultimately used to set up the following Python code block. Where up on the input of a MEP family, it's evaluated against all the enumerations, and therefore the type, part type of the element is output. And then later on, some logic is applied within the MEP components. So we can program that into logic loops. It also helps to compress the script into something that is more easily or traditionally evaluated. So it's easier to understand the logic behind this program. And you can see how this is all based on the Python language. It's Iron Python within Dynamo. We are building up towards having a look at what generative design is. But what's of essence here is to understand that there are inputs to a graph like this. So you might have height, width, thickness, number, any number of items that might be an input. And then you would have outputs. And outputs could also be numerous. The essence of generative design is that it is a multivariable optimization, based on constraints. We'll have a look at that later and where we can learn about that. Just to show you what the interface looks like on Dynamo today, we've got the typical Revit nodes. So there, for instance, are our elements. So we can get parameters and set parameters and do all sorts of interesting things with Dynamo. These are the native nodes. And then we have the packages that we install. So there's the Archilab packages, for instance. There are specific things that were programmed for Revit elements, and there we can see we get bounding boxes and all sorts of things over here. So a lot of the commands, if you want, within the packages were programmed for giving us commands that are over and above what automatically Revit gives us. So we look at the family document, for instance, we can find out what the family parameters and family types are. There's some more documents. So lots and lots of things. So we can achieve the same thing using Python if we know how to use the API, but it's just faster to use whatever is given over here. So specifically with generative design, you'll see that in our packages, in the management, we can search for a package, and you might choose to install the package for generative design. Right. So there we can see there's a refinery toolkits, and refinery is what is the optimization I've already installed them, and you'll see them over here. There's the refinery toolkits. There's one for massing. And you can see there's some site parameters. We can do crash tests, generation of buildings, site, space plan. So these commands are important, otherwise we would have to program them ourselves. Because we can download the packages, we can use whatever is within them. You'll see some of them in a program shortly. Right, so we've got our packages, which we can download off the internet. We've got our native Revit nodes that are displayed over here, and they are put together into a program. And the typical program would look, this is from a space planning graph, which one can download from the generative design or refinery samples. And this is what a typical graph would look like. So one would look for a file path, one would read some information from an Excel spreadsheet, basically a noise factor for rooms, and so you choose what size configuration, and ultimately this feeds into quite a complex graph. And I've had a look at this type of graph, and specifically with the view of what this graph does is optimization of floor space and design. But if you can think about where this would be most applicable, would be something like a hospital, for argument's sake. A hospital is very expensive to build per square meter. And so hi Mansur, welcome. What we can do with hospitals is to try and minimize the floor space, and the typical program would look something like this. So this has to be set up. Somebody has to program this, and somebody has to input this. I maintain that it is more the job of a programmer to do this kind of programming, or a statistician as well, to make sure that it is correctly applied, that the Revit manager would be able to advise what the idea behind such a script would be, because it's being applied to architecture or whatever building discipline is relevant. Just note that it would take quite a bit of skill and intelligence, more suited to topological mathematicians and statisticians, to do something that is very complex. It doesn't have to be so complex, but this is what a typical script, you can see it's quite large. That's what a typical script would look like for the optimization of some rooms. And it would run through, in this case, 3,628,799 iterations, possibilities. It will then evaluate those solutions. So it would run for a few days probably on this computer. It's a very fast computer, it would run faster. And then you would find the optimal solution from there. So I can't run this obviously within the space of time we have for the webinar. So again, we can automate using Revit nodes. We've seen Revit packages, and we can download the generative design packages. And then we can also use Python nodes and the Revit API. What is the Revit API look like? So this is what the Dynamo website looks like, Dynamo BIM.org. It's a wonderful place where one can learn. Computational design and open source community. There's a great community out there that help each other with their solutions. You see some of the interesting solutions that people have come up with for facades in the background. Lots of interesting things that one can do. And then there's a Dynamo Primer. I usually say to my clients most before they come for training, although we can train them on the job as well for what is necessary. This is how one learns about what is Dynamo and how can one go about learning Dynamo. So it's a very good thing to work through. The Dynamo Primer will teach you exactly how to put these scripts together, how to manage the program, how to work with data and data nodes, how to work with mathematics and logic and strings and colors. There's some geometry and vectors and points and curves, surfaces and solids and meshes and geometry, lines, and then we get into scripts, and text, Dynamo for Revit, the connection, and there's a lot that one can go about over here. Dictionaries, how to create dictionaries, they're quite important when you work with them. Custom nodes, if you want to have nodes that you use often, you can put them into custom nodes and packages. We've already had a look at some of that. Geometry, how to create some geometry, how to type in geometry, and best practices, how to create these graphs. So this would be the start for somebody who wants to work with generative design, if they want to put together their own question. Basically, you ask a multivariable question with possibly a multivariable output, and you would like that answered. So you would have to ask Revit in a specific way about the information that is within it. And this package over here would be beginning, or this primer would be the beginning to learn how to ask the question. Because the computer needs to understand a question. The idea behind the question would typically come from the ideas person in the company. That would be the BIM manager or somebody within the company that understands the workflow. Very useful, the Dynamo Primer. And that's freely available on the internet. It's very easy to get working with that. See, there's even a downloading file. We're working with this. Right? And there we can see some more downloaded files. So you can download these files and you can learn how to work with the commands that you've got there within Revit. Dynamo is built into Revit installation automatically. So if you had your Dynamo, you'll see it's on the Manage tab on the right-hand side. Mine's grayed out because of Open Dynamo. There is the Dynamo command. The Dynamo player that you see next to that, that is where you put the scripts into a directory, and then guys can very easily play that against their model. Here we can see an example of a Dynamo player. And these are some built-in ones that Revit automatically has. And so you can see we've got all sorts of scripts that we can immediately play. And they've also got inputs and outputs, so all levels above. I'm going to add some levels over there. You close this, close Dynamo. Let's do that quickly. There. And this one over there. And then we can see we can have some inputs into the script. And they would like to have some information that we can input. Right, so one does this within Dynamo in a specific way. One right clicks on the node and says add it as an input, and it will appear like this when we play that file. Pretty much the same thing within generative design. So when we ask a question, we need to ask the question using Dynamo. Then when we can't ask the question using Dynamo, we resort to the Revit API docs. This is the API. So not strictly speaking, not everything in Revit is possible in the API docs. There are very few exceptions, but you can, if you know how to use the language, you can pretty much use everything over here. So 2021 isn't available yet. You can see some examples of code that was used. So if you want to learn how to work with with coding, this is where you can learn that. And there are examples in different languages. As we can see, there is the code that was used to generate this. And that's C#, and there's Python. So we didn't used to have Python examples, but now we've got Python examples. And you can see that we've got all sorts of interesting scripts here that we can learn from. And that is only a beginning. And once you understand how to do that, then we need to apply that in our own method to ask those questions. So asking those questions is important. We've got, just to repeat, we've got the Revit database itself, or the Revit file. Then we've got the Dynamo, with which we can ask a question with nodes and with packages. And if the packages and the nodes are not available, then we can use Python and the API of Revit, which looks something like this. And there in the Autodesk Welcome Cafe, I'm just going to mute you. You're welcome to ask questions at any time. So just to recap, we've been talking about Revit, and the topic is generative design. And just as a recap, we've got in Revit, we've got Dynamo. And when we open Dynamo, we can create scripts. And within the scripts, in the graphs, we can also ask or include nodes that references the API over and above the nodes that we get natively from within Revit, and also what we get from packages. So at the top here, we'll see the nodes that we get with Revit, typical nodes that we can have over there. So for instance, there we can find some commands that we can use within Dynamo. And then below that, we've got some of the packages that we downloaded, including the generative design, and we can manage that from within packages. So the ultimate point of this is that the graph might look something like this. It's a logical flow chart where we execute a program and having multiple inputs possibly and multiple outputs. And the purpose of this is to do machine learning, or sort of a brute force attack on this program where you generate, say, hundreds of thousands or millions of iterations of a design, and then we can pick and choose the designs that come up with the best solutions for us. And the point is that we need to be able to ask the question. So that is why we have Dynamo. A good place to start is dynamobim.org. There is the Dynamo Primer. Right? So learning the Dynamo Primer will teach us how to ask the question using these nodes. You can see how the wires are connected to the little things there. And then we've got the Revit API, which is where we are at the moment. So if you had to use Python, you would then be able to leverage anything within the Revit API. So if you have a look over here, for instance, there is, let's have a look at the element class. There's the element class. This is purely a programming terminology. Element class, we've got the element members, element methods, and then also the element properties. And we can leverage any one of these things over here. So there's the parameters property that gets all the parameters within that element, and we can cycle through the parameters. So everything that Revit does in the graphical user interface, that is leveraged upon the API, which is this is it. So this is actually how Revit's commands or the object model class is put together. Right, so it's a great person over here. His name is Jeremy Tonic. He's one of the best, and he does some very interesting commands as well. So you can see it's quite mathematics intensive, but he's written some great stuff that I've learned from in the past, like Revit, the API, although I think he's more focused on Forge and some of the other APIs that are available today in the cloud. And just to go back to our itinerary today, so we've had a look at Dynamo. What is all of this Dynamo? So page here. Then you have to look at Autodesk Refinery or multivariable optimization. So what is that? This is Project Refinery Beta, as you can see on the screen here. You can download that today. And this is, I've opened already a link at the bottom over here to the ebook, and to discover more is the generative design page. And this basically goes through why is it used, how is it used, what goes into it. You have to generate, you have to, this is the stage where the design options are created by the system using algorithms and parameters specified by the designer. So that's what we were talking about until now. Using Dynamo, the API, Python, packages, we can ask questions. Then designs are generated in the previous step are now measured and analyzed and how well they achieve their goals defined by the designer, and then the solutions are ranked. We can go through an evolution process, an exploration process, and an integration process. And ultimately, we are looking for the best solution. Why would we want to have things like this? Well, we would like possibly to have the optimum layout of furniture, spaces, volumes, whatever question we want to ask of the Revit model, we can ask of the Revit model, and then we can do multivariable optimization. There you can see an example on the right-hand side where some of these are shown. And like I've explained earlier, if you have the design envelope, that little blue area or the cyan area that you see for the different solutions, that is how they fit the criteria for that question. This is a very short piece of information about what generative information is. I'm just going to page through it, just show you examples of where this played a role. So on the right-hand side there, you can see some of the facades that were created. There's all the different layouts that were created. Autodesk evaluates 10,000 design options using its own generative design solution for the design of an office, which takes into account things like preference, adjacency preference, low distraction, interconnectivity, daylight, and views of the outside. So trying to have a computer answer a question that a designer asks. And that really is the biggest thing of all. Right. So being able to ask a question as a designer, having a programmer to interpret that for the computer, and then having a computer to do the hard work, and then ultimately to evaluate that design. So that is so. Here is an example of a generative design for a facade. See, very modern. That is the Kuwaiti Children's Hospital. You see there is another example. So mostly facades that they show there. And then here we can see there's another primer. And this is the generative design primer. So when you look at Revit itself, I played around with this earlier, and this is essentially a room where solutions were generated. And the generative design looks something like this. Right? So understand that in the background, when you open this generative design study, just wait for it to open quickly. So when you open the generative design study, it comes up with these questions that we can already answer using a computer. So instead of us asking the question, we can get these automatic tasks for us. So for instance, step grid object placement, and it would work with a method. How would we like to do this? We can select the room. And we can select a family. So again, I'm not going to run this. Take some time to run for the computer to run through it. But you can then set the variables and the goals and the constraints, the generation settings, and ultimately come up with a solution that looks something like this based on some runs that we've done before. So if we look at the explore outcomes, these are some of those studies. And there you can see the different results that were generated. Each one of those then has a certain output for the design criteria. See how it changes if I click on the different solutions. And you can also limit them to a specific area that you might be interested in. So if you were interested in solutions that fit those, we'll highlight those for you. Maybe these ones there. We can filter them out. So you can use filters to say only solutions that fall within there's no solutions. You can make this a little bit larger. We should pick up one or two just now. Here we go. There's two solutions. And so we can filter based on what information we have over there. We can filter the solutions out and apply whichever one is then most relevant or sort of within the area that we're looking for. And that's how we can choose then to generate the Revit elements on the right-hand side there. So once the study is done, then we can generate those Revit elements. And it looks like that. So placement, the optimization, the placement, that is what we can do there. Now, when you create a study, you are limited to the questions that they've got there. But with Refinery, with Autodesk Refinery, remember, you can ask the question using Dynamo and Python and the Revit API. And with Refinery, you can then optimize that automatically. So you can ask any question of the computer and we can run through it. There we can see introduction. This is a great, just like the Dynamo Primer, which looks like that, which is the base of the underlying theory behind this. Here is then a generative design solution. You can see how it's coming up with different solutions. Okay, so what is it? Generative design. And it's great reading for you to go through. Really explaining in detail what it is that we want out of this. Some examples. Mars Innovation District of Toronto. Okay. See some examples. There's a bit of furniture design, so how can we get some good furniture out of this, good design out of there? And also further analogy, in this case it was used for transport, to work out what is the optimum route for transport. And it's just going onto the Dynamo part of it again. And so it goes through. So there's a how to go about installing generative design, setting up the graphs, how to run it, and then visualization of the results. So it sets it up in a table, either as a scatter plot, parallel coordinates. Looks very familiar. We've already seen something like that. And choosing the right visualization. There's the refining toolkit. We've seen those downloaded in Dynamo. Then there are some sample workflows. So you can work through these. It's freely available on the internet, but it does require you to be able to ask the question using Dynamo, using Python, using the API, using packages that are available, finding outputs and inputs, and then optimization of that using a computer to do the hard work for you. And then you can come up with the optimal design. As we go into the fourth industrial revolution, these are the technologies that will be applied by the best companies. And you might also think about hiring a generative designer. Okay? There you can see what are these people about. What would the job description for something like that be? Okay? You would have to work collaboratively within a team of designers and developers. You have to translate complex design strategies into developer-friendly and scriptable concepts. So what I've been referring to as you need to be able to ask the question. You work with a variety of data inputs and methods, but flexible parametric generative models, models that integrate simulation and optimization components, and research design strategies and implement research scripts and create 2D and 3D visualizations of data and designs. So it sounds like a mouthful, and it is a bit of a learning curve, but it's wonderful that in an age where we often think about automation as being taking people's jobs away, here you can see how it's adding so much possibility for people to create new jobs and to create better designs, which make us more competitive in a global sense, and which also come up with better solutions, better architectural solutions, better buildings for people to live and work in. And so there's so much scope within this technology for people to live and express themselves out through the design, which isn't traditionally the job of architect, but more a programmer or a person that scripts these questions into the solution. So all of this available free on the internet for your perusal, and I strongly recommend that we have a look and think about how this can apply to our industry in general into the future. With that, it concludes the overview of the presentation. I don't know if anybody has any questions that I might field. So we've got Kathy, Aldred, Mansoor, you're still here. Razik has given his apologies, he's already had to leave. So if you guys have any questions, please let me know now. I see nobody's got any questions. All right. Well, I hope you've enjoyed it. I've done a bit of an anorak, but I find this very exciting and very interesting for the future, and it makes me positive that we can do some great things here in South Africa as well to use this technology to take on the rest of the world. I hope you have a great day further, and until I see you next time again. Thanks. Bye. I'm going to stop recording and unless you guys want to ask me something off the air, then I'm going to close the meeting. Good. Thank you, Paul. All right. And sir, have a great day further. Just